Good evening, students. In the last class, we discussed questions till question 30. Now, let's continue our discussion with question number 31. Okay. If y is equal to e power m sin inverse x, then 1 minus x square into y double dash minus x y dash is equal to. Okay. It's a standard result. If you can remember it, directly you can write m square y as the answer. In case if you don't know, then what to do, that I will explain now. Y is equal to e power m sin inverse x. Let us differentiate once. y1 is equal to e power m sin inverse x into m into the derivative of sin inverse x, which is 1 by root of 1 minus x square. Cross multiply. Root of 1 minus x square into y1 is equal to m into e power m sin inverse x. Again, we shall differentiate it with respect to x. We get root of 1 minus x square into y2 plus y1 into 1 by 2 root 1 minus x square into minus 2x. That's equal to m into the derivative of e power m sin inverse x, which is e power m sin inverse x into m into 1 by root of 1 minus x square. Let us multiply this equation with the root 1 minus x square. We get 1 minus x square into y2 plus, minus here because of this minus. Here 2 gets cancelled. When I multiply by root 1 minus x square, this also gets cancelled. So we have minus x y1 is equal to, that root 1 minus x square gets cancelled, m square into e power m sin inverse x. E power m sin inverse x is y. So 1 minus x square into y2 minus x y1 is equal to m square y. Second option. Okay, let's have a look at this question 32. The function f of x is equal to mod x minus 3 is continuous at x equal to 3, not continuous at x equal to 3, differentiable at x equal to 3, neither continuous nor differentiable at x equal to 3. Let us have a look at mod x minus 3. The graph of mod x minus 3. Okay, this is 3, 1, 2, 3. Mod x, this is the graph of mod x minus 3. As you can observe, it is continuous everywhere and it is not differentiable at 3. At 3, there is a sharp edge. So the answer is first option, continuous at x equal to 3. In general, you remember this, modulus of x minus a is continuous everywhere and non-differentiable at x equal to a. Everywhere else it is differentiable also. At a, it is non-differentiable. Continuous everywhere but not differentiable at x equal to a. Okay, so first option is the answer. Then let us have a look at question 33. The value of k, which makes the function defined by f of x is equal to sin 1 by x if x not equal to 0 and k if x equal to 0 is continuous at x equal to 0. So they have already given that function is continuous at x equal to 0. If that can happen for what value of k, that is what we have to find out. See, f of x is equal to, it is defined as sin 1 by x if x not equal to 0 and it is k if x is equal to 0. F of x is sin 1 by x when x not equal to 0 and it is k when x is equal to 0. So it is continuous at x equal to 0. Continuous at x equal to 0 means limit extends to 0, f of x must be equal to f of 0. So limit extends to 0, f of x. F of x is sin of 1 by x. That's equal to f of 0. F of 0 is equal to k. Right. Now we look at this. Sin 1 by x. Sin 1 by x. Sin theta. We know that sin theta varies from minus 1 to 1. Whatever may be the value of theta or whatever may be the value of 1 by x, sin 1 by x will always lie in between minus 1 and 1. That's what we know. But we don't know exactly where this will, what will be the value of this when x tends to 0. So this limit does not exist. Limit extends to 0, sin 1 by x does not exist. Hence, this function can never be continuous. Whatever may be the value of k, this function will never be continuous. Okay. So the answer is none. There is no value of k which will make this function as continuous. So I'll explain one more problem which is very similar to this. If the function is defined as, instead of this, it is defined as x into sine 1 by x when x not equal to 0, then what is the value of k? If they ask this question, then it will become x into sine 1 by x. So I can write this as limit x tends to 0 x into limit x tends to 0 sine 1 by x. Okay. Now limit x tends to 0 x will become x. Sorry. Limit x tends to 0 x will become 0. Into this value limit x tends to 0 sine 1 by x, a finite quantity, a finite value between minus 1 and 1. A finite quantity between minus 1 and 1. 0 into that quantity will be equal to 0. Then the value of k would be equal to 0. Right? Say, if you consider only this limit x tends to 0 sine 1 by x, this limit does not exist because we only know that it takes a value between minus 1 and 1. Between minus 1 and 1 there are infinitely many real numbers. Among them, this function will tend to which value we don't know. Therefore, only if you consider this limit does not exist. But if you consider the product of these two, then this will tend to 0 and this is the finite quantity between minus 1 and 1. So their product will be equal to 0. So if that is the case, then k value would have been 0. But now none of this is the answer with the given function. Okay. Let's look at 34th question. If y is equal to square root of sin x plus root of sin x plus root of sin x etc. up to infinity, then what is dy by dx? There is a direct formula here, that is if y is equal to root of f of x plus root of f of x plus root of f of x etc. up to infinity, then dy by dx is equal to f dash of x divided by 2y minus 1. Remember this formula, this is a shortcut. If you know that formula, directly you can write the answer. In this given problem, in place of f of x we have sin x, so f dash of x is cos x. Hence dy by dx is equal to cos x by 2y minus 1. Cos x by 2y minus 1. First option is the answer. I advise you to remember this formula. If you don't know the formula, then what do we do? Then also you can solve this problem. Let me explain how. I'll explain this only instead of sin x. Okay? So I have root of f of x plus root of f of x plus root of f of x etc. till infinity. So there are infinitely many roots and there are infinitely many f of x. Among them, if I remove one of those roots and one of those f of x, if I remove, still there are infinitely many square roots and infinitely many f of x. So what is left after this? Root of f of x plus root of f of x plus root of f of x up to infinity. So the remaining things can be written as y. So you can have y is equal to square root of f of x plus y. Square this, y square is equal to f of x plus y. Now differentiate this. 2y into y dash is equal to f dash of x plus y dash. Bring this y dash to this side. Take y dash as common. Y dash into 2y minus 1 is equal to f dash of x. Hence y dash can be written as f dash of x divided by 2y minus 1. That means dy by dx is equal to f dash of x divided by 2y minus 1. Okay? You need not remember the proof, just for your knowledge I have explained it. Should remember this formula. Directly you can write the answer. Okay. Let's look at this question. 35th. The sides of an equilateral triangle are increasing at the rate of 2 cm per second. Sides are increasing at the rate of 2 cm per second. Then the rate at which the area increases when the side is 10 cm. That is what we have to find out. We have to find out dA by dt. I'll say let x be the side of the equilateral triangle. It is increasing at the rate of 2 cm per second. Dx by dt is equal to 2. Okay. Then area. What is dA by dt? That is we have to find out. When x is equal to 10 cm. When x is equal to 10 cm, what is the rate of change of area? That is what we have to find out. We know the formula of for an area of an equilateral triangle, which is equal to root 3 by 4 into a square. If a is the side, here I have taken the side as x. So root 3 by 4 into x square. Now differentiate this with respect to t. dA by dt is equal to root 3 by 4 into 2x into dx by dt. Okay. substitute root 3 by 4 into 2 into x. What is x? X is 10. Okay? Into dx by dt, which is 2. So 2 into 2, 4 gets cancelled. Answer is 10 root 3. dA by dt is equal to 10 root 3. This suggests that area is increasing at the rate of 10 root 3 square centimeter per second, which means third option is the right answer. Then 36th question. Integral of dx by x into x square plus 1 equals dx by x into x square plus 1. So here again we know one direct formula. Integral of dx by x into x power n plus 1 is equal to 1 by n log mod x power n divided by x power n plus 1 plus c. Remember this formula. I think most of you know this formula. Okay, so if we use this formula, here in place of n we have 2. So integral of dx by x into x square plus 1 is equal to 1 by 2 log mod x square by x square plus 1 plus. That's equal. Again, as you can see, this answer is not available in the options. So what do? I will write log x square by x square plus 1 as log x square minus log x square plus 1 plus log m minus log n. Log m by n I am writing as log m minus log n. Okay, then half log x square minus 1 by 2 log x square plus 1. Log x square can be written as 2 log x, so 2 gets cancelled, log x, or you can write log mod x minus 1 by 2 log mod x square plus 1 plus c. So log mod x minus 1 by 2 log x square plus 1 plus c. First option is the correct answer. 37th question. Integral of dx by sin square x into cos square x is sin square x into cos square x. Okay. See, we have dx by sin square x into cos square x. In the numerator there is 1. That 1. You can write dx as 1 into dx. That 1 I will write it as sin square x plus cos square x. Sin square x plus cos square x divided by, we have sin square x into cos square x into dx. This is equal to. Now I will split this into two terms. Sin square x divided by sin square x into cos square x plus cos square x by sin square x into cos square x. So first term you will have sin square x divided by sin square x into cos square x. So that sin square x gets cancelled. You will have 1 by cos square x plus the second term is cos square x divided by sin square x into cos square x. There cos square x gets cancelled. We will have 1 by sin square x into dx. Take this cos square x to the numerator. As it goes to the numerator, it will become secant square x. Similarly, 1 by sin square x is nothing but cosecant square x into dx. What is the integral of secant square x? Which is tan x. The integral of cosecant square x is minus cot x plus c. Tan x minus cot x plus c, which is the third option. Okay, let's move to the next question. Question number 38. If integral root of x square plus 4x dx is equal to x plus 2 by 2 into root of x square plus 4x minus 2i1, where i1 is. It is given that integral of root of x square plus 4x dx is equal to x plus 2 by 2 into root of x square plus 4x minus 2 into i1. Then what is the value of i1? That's what we have to find out. Okay. So let us consider this integral of root of x square plus 4x. I have to complete the square here. Already there is x square plus 4x. If I add another 4 here, then it will become x plus 2 whole square. So I will add and subtract 4. X square plus 4x plus 4 minus into dx. That's equal to integral of root of x plus 2 whole square minus 4 is there. I am writing it as 2 square. Now we can compare this with the root of x square minus a square. As we know, the formula for integral of root x square minus a square is equal to x by 2 into root of x square minus a square plus minus a square by 2 into log mod x plus root of x square minus a square. That formula we know. So let us make use of that formula. X by 2, that means x plus 2 by 2 into root of x square minus a square, which is x plus 2 whole square minus 2 square, minus a square by 2, 2 square by 2 log mod x plus, x means x plus 2 here, plus root of x square minus a square. X means here x plus 2. X plus 2 whole square minus 2 square. This is nothing but x square plus 4x plus 4 minus 4. So we get x plus 2 by 2 into root of x square plus 4x minus 2 into log mod x plus 2 plus root of x square plus 4x plus c. Okay, so now look at what they have given here. X plus 2 by 2 into root of x square plus 4x, that is available, minus 2 into this, which means I1 is log mod x plus 2 plus root of x square plus 4x plus c, which is the first option. Then 39th question. Integral 0 to 2 by 3 dx by 4 plus 9x square. I'll take 9 as a common factor here. 0 to 2 by 3 dx by 9, if I take out that, we'll have 4 by 9 plus x square. Here 1 by 9. So I'll rewrite this as 1 by 9 integral 0 to 2 by 3 dx by x square plus 4 by 9 is there. I am writing 4 by 9 as 2 by 3 whole square. So this looks like 1 by x square plus a square. Integral of 1 by x square plus a square is equal to 1 by a tan inverse of x by a. That formula we know. 1 by 9 into 1 by a, that is 1 by 2 by 3. Tan inverse of x by a, which means x divided by 2 by 3 from 0 to 2 by 3. That's equal to, here 3 ones are 3 3s are 3 into 2 6. So you have 1 by 6 into tan inverse of, apply upper limit 2 by 3 by 2 by 3, that will give you 1 minus lower limit, if you apply we get tan inverse 0. So 1 by 6 into tan inverse 1, which is pi by 4, tan inverse 0 is 0, so the answer is pi by 24, which is third option. Okay. Next, 40th question. Integral 0 to pi by 2 root of 1 minus sine 2x dx is equal to 0 to pi by 2 square root of 1 minus sine 2x dx. I will write 1 as sine square x plus cos square x and sine 2x as 2 sine x cos x. Then you can write this as 0 to pi by 2 square root of sin x minus cos x whole square dx. Square root of sin x minus cos x whole square will be equal to modulus of sin x minus cos x. Okay. Now whether it is sin x minus cos x or cos x minus sin x depends on whether sin x minus cos x is positive or negative. So here till pi by 4, between 0 to pi by 4, cos x is greater than sin x. Therefore, modulus of sin x minus cos x will become cos x minus sin x. And from pi by 4 to pi by 2, sin x is greater. Therefore, there in that interval, mod sin x minus cos x will be equal to sin x minus cos x. So I will write it in this way: 0 to pi by 4 mod of sin x minus cos x plus pi by 4 to pi by 2 modulus of sin x minus cos x into dx. In this interval, sin x is less than cos x, so sin x minus cos x is negative. So modulus of that will become cos x minus sin x plus, here sin x is, in this interval sin x is greater, so it will remain as sin x minus cos x. Sorry, it should be pi by 4 to pi by 2. Now, integral of cos x is sin x, integral of minus sin x is plus cos x. From 0 to pi by 4 plus minus cos x minus sin x from pi by 4 to pi by 2. Apply the limit. Sin pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2, 1 by root 2 plus root 2. 1 by root 2 plus 1 by root 2 will give you root. Minus, when I apply the lower limit, sin 0 is 0, cos 0 is 1. Root 2 minus 1. Minus of, I have taken minus out, so cos x plus sin x. If I apply the upper limit, pi by 2, cos pi by 2 minus sin plus sin pi by 2, that will give you 1. Minus, now if I apply the lower limit, cos pi by 4 plus sin pi by 4, that will give you root. Okay? So it will become root 2 minus 1 plus minus 1 plus root 2. So altogether, after all the simplification, we get 2 into root 2 minus 1. 2 into root 2 minus 1 is the fourth option. Next, question 41. Area lying between the curves y square equal 4x and y is equal to 2x. Y square equal 4x and y is equal to 2x. Y square equal to 4x, as we know, it represents a parabola with vertex at origin and facing right side. This is the parabola. Y square equal to 4x. Then y equal to 2x is a straight line passing through origin. Let us say, okay, this is the line y equal to 2x. We are asked to find the area of this region. We want the area of this region. For that, we need the point of intersection. One point is the obvious point, which is the origin. What is the other point that we shall find out? We shall solve these two equations. Y square is equal to 4x, y is equal to 2x. In this equation, I will substitute y is equal to 2x. So that will give you 4x square is equal to 4x. So bring it this side. 4x into x minus 1 equal to 0, which implies either x equal to 0 or x equal to 1. X equal to 0 means y is also 0. When x equal to 1, y is 2. So 0, 0 and 1 and 2 are the points of intersection. 0, 0 is obvious one. This point is 1, 2. Now if I draw one line here, this will be, its equation will be x is equal to 1. So required area is equal to integral 0 to 1 f of x minus g of x. What I am doing here is, first I am finding the area bounded by the parabola with the x-axis between the lines x equal to 0 and x equal to 1. Then I will find the area bounded by this line with the x-axis between the lines x equal to 0 and x equal to 1. So I will take the difference of those two, that will give the desired area. So area bounded by parabola, y square equal to 4x, so y is equal to 2 root x minus y is equal to 2x. We have into dx. 2 I will take out. Integral of root x is x power 3 by 2 by 3 by 2 minus integral of x is x square by 2 from 0 to 1. Apply the limit 2 into put x equal to 1 here, we get 2 by 3 minus 1 by 2. When I apply the lower limit, both the terms will become 0. So you get 2 into, take LCM, 6 is LCM, 3 2s are 6, 2 into 2 is 4 minus 3. So 1 by 6, 2 into 1 by 6 is equal to 1 by 3. So second option, 1 by 3 square units is the answer. Okay. Let's have a look at 42nd question. The area of the region bounded by the y-axis, y equal to cos x, y is equal to sin x, between 0 and pi by 2. Let me draw the graph of sin x and cos x. This is the graph of sin x and this is the graph of cos x, as we know. this is pi by 2, right? We want the area of the region bounded by y-axis, cos x and sin x. So this area, this is what we want to find out. Okay? So to find this area, what I do is, I will draw one line here. This line is nothing but x equal to pi by 4. You know, their point of intersection is at pi by 4. Sin x and cos x meet at pi by 4 in the first quadrant. So first I will find the area bounded by cos x with x-axis between 0 and pi by 4. Minus, I will find the area bounded by sin x with x-axis between 0 and pi by 4. That will be the required result. Okay? So integral 0 to pi by 4. First the area bounded by cos x minus the area bounded by sin x. Cos x minus sin x into dx. Integrate it. Already we saw this integral in the other problem. After all the simplification, you will get root 2 minus 1 square roots. The order and degree of this differential equation. Okay? So order is 2 because there is d square y by dx square. And here the power is 3 by 2. So you square this equation. When we square this equation on RHS, here the power will become 3. On RHS, we will have d square y by dx square whole square. So the degree is also 2. Order is 2, degree is 2. Second option. 44th question. The solution of dy by dx plus y is equal to e power minus x. Y of 0 is equal to 0. When x is equal to 0, y is also 0. When x is equal to 0, y is equal to 0 means whatever the answer we get, that should pass through 0, 0. That means when I put x equal to 0, we should get y also as 0. Okay, look at the first option. If I put x as 0 equal 0, there is 1. 0 minus 1 is minus 1. So you are going to get y equal to minus 1. So this cannot be the answer. When x equal to 0, we should get y equal to 0. Here if I substitute x as 0, 0 into e power 0, 0 into 1, that is 0. So this option may be the right answer. First option is ruled out. Look at third option. If I put x as 0, 0 into this, that is 0, plus 1, 1. When I put x equal to 0, we are getting y equal to 1. So this option cannot be the answer. Look at fourth option. There if I put x as 0, I am getting 0 plus 1, that is 1, into e power 0, which is 1. 1 I am getting. When I put x equal to 0, y is equal to 1 we are getting. So first option, third option and fourth option are not the answers. The only one option left, which is the second option, that's the answer. Okay? This is the easiest way to solve this problem. I mean, of course it depends on what options they give. So today we are lucky that 3 options does not pass through 0, 0. Hence that whatever the option left, the second option is the right answer. Okay. But let us imagine a worst scenario where all the 4 options pass through 0, 0. Then what to do? I'll tell you how to do it. Okay. So we have dy by dx plus y is equal to e power minus x. This is a linear differential equation because you can compare this with dy by dx plus py equal to q, where p and q are either constants or functions of x only. So from this we get p is equal to 1, q is equal to e power minus x. Now I will have to find out the integrating factor. Integrating factor is given by e power integral of p dx. E power integral of 1 into dx, that's equal to e power x. Okay. Now the solution is y into integrating factor, that is y into e power x, is equal to integral of q into q is e power minus x into integrating factor, which is e power x dx. So e power minus x into e power x, 1 you get. So y into e power x is equal to integral of 1, that is x, plus given that y of 0 is equal to 0, that means when x is 0, y is 0. Put x equal to 0 and y is equal to 0 in this. LHS is 0, RHS is 0 plus c, which means c is equal to 0. So the answer is y into e power x is equal to x. You can multiply this equation by e power minus x, that will give you y is equal to x into e power minus x, which is the second option. Okay. Let us look at question 45. If theta is the angle between any two vectors a bar and b bar, then magnitude of a dot b is equal to magnitude of a cross b when theta is equal to. Magnitude of a dot b is nothing but mod a mod b cos theta. And on RHS, mod of a cross b is equal to mod a mod b into sin theta. Mod a mod b gets cancelled. cos theta equal to sin theta, that can happen only when theta is equal to pi by 4. Second option.